Then we have HDB scan, hierarchy density based spatial clustering of applications with noise. So these are different nodes which have their own significance. Might not know all of them, so that's not a problem though. But these are the nodes, these are the Python nodes that are applicable with this. Okay, great. So now we have generated an output here. We have generated a model here. Output we haven't. Let's double click on this and check it. Right. So this is the a random forest model that we've generated. The training data was how much? 2148. The input fields, we took the input fields as eccentricity and solidity. Both are real and continuous input fields. And the estimators were 10. The OB score is false. Minimum sample leaf is 1. So these are the various model parameters that have been generated. Let's click on predictor importance. So we can see here which of these, what is the importance of these. Now, as per the random forest model, F1 is what? F1 is solidity and F2 is eccentricity. So F1 has the greater importance and when compared against the eccentricity. So that is one predictor importance assessment that you can conduct. If I click on advanced, speed up scoring performance, well, there is nothing out here. So I click apply and I click OK. So that was how you applied the random forest Python node, which is part of the Python node, and we generated its nugget. Now that's a nugget that we have. This is a nugget, and this particular symbol is for a random forest. So you generated the random forest nugget for pistachio data sets, for pistachio features data set. So if you want, you can add a comment here also. Let's right click on this. You can right click and add a comment. No, we do not have any provision here for. Yes, we have. So what do we see here? Well, what is this? Well, that is the random forest nugget pistachio data set, and has been implemented using Python nodes. Python node or nodes, as we call it. So this is how you can provide the comments also to the work that you're doing. Fine, let's save this. Let's come back here into we're in day 4. Yes, so we can see here these are the two different data sets that we had exported the MX Excel to. I'll minimize this and fine. So this is what we have now. Let's move on to Spark. Well, when I click on Spark, these are the 4 nodes that they have multi-layer perceptron. Now, multi-layer perceptron is typically that pertains to neural network. Now, that is not so quite so different from the neural network out here, but we have not run any neural network node for the modeling Spark. So if I select supposedly a multi-layer perceptron, I bring it over here. Now let's see what can be made out of it. I'll connect the pistachio data set with multi-layer perceptron. Right click here and I click run. Yes, now it is going to throw up some error because we have not actually gone and looked into the node itself. What is it? So target field is required. So fine, let's edit this. So I right click, I left click on this, right click on multi-layer perceptron, click on edit. Fine. So use custom field assignments. What is the target that we have? Well, instead of this, let us take some other data. No, we'll continue with this data set. So what is your target? Eccentricity is the target. Continuous field cannot be placed in the list. Okay. And let's say compactness. Oops, continuous fields cannot be placed in this list. Now we do not have any other. So now this issue is going to pop up because we do not have any dedicated. Yeah, here also it is the same thing. So we either need a 0 or 1 type of value or a Boolean type of value. So of course, we'll not be able to add those because anyway, it's a multi-layer perceptron. So you need typically caters to logistic regression kinds of data set, and which we currently don't have. So, but this is how we will connect. And maybe if we get a chance, then I'll also run this perceptron for you all in upcoming sessions. But for now, this is how it looks like. And so this is something you can keep on the back of your mind, that in Spark nodes, these are the 4 nodes that are available to us. I'm removing this because this is not going to be of any help. Let us take k-means AS. It is expected that y'all understand what are these nodes. Yeah, I mean, what are these methodologies, even as you might not always understand what are the nodes herein. So let's right click and edit it. So what are the input fields? Well, I'm taking eccentricity. I click apply, I click OK. Now let's run it and see what shows up. Okay, it looks like it's going to run. So you can see here it's executing and it's been 20 seconds elapsed so far. So typically you all are expected to know these nodes and what is the significance of these nodes and how are they the theoretical aspects pertaining to these nodes. I mean, they are very well provided for by the SPSS modeler, but unless you know the theory, underlying theory behind it, you might not always be able to get the best out of the software. So that is something that is expected of you all. Yes, now we got another nugget. That's another nugget that we generated here that you're seeing. All right, so let's open this nugget and see what's therein. It's taking longer. Slow down the system. Now, these are the k-means cluster centers are provided to you all. These are the dimensions. These are the centers values. If you click on cluster centers, yeah. We don't have any annotations. If you want to click on preview table, it will show you. So that's a preview table that we have generated. That's the table from which the data set was taken in the first place. So anyway, this is not quite necessary. So this is how your k-means cluster output has been generated using the Spark nodes that are available to us. And fine, the last node that we have here is that of IBM's SPSS text analytics. And we don't have any text data that we can work or look upon, but still, let us see what can be done. Text link analysis. Let's bring it here and see what is available here. If we double click on that, now it is going to ask us for ID field and a text field, language field. So we need to have the entire file in text format that we can use. For today, we do not have. I'll generate the text file accordingly, and then we'll see what we intend to work upon. Because I think there is a template also that is available over here. You can load from the resource SQLite read-only, attempt to write a read-only database. Okay. Row index of range. Okay.